Hello everyone, good morning. It's another lovely Thursday morning. I hope we're all doing well. I hope we're all doing fine. I hope your day has been going well. Okay, so today we're going to be doing mathematics for the seniors in the house, and we are going to be continuing our last from our previous class. Okay, but before that, I'll show you another trick today. Okay, so now we're still on the mental matrix segment, so let's start with that. Now let's look at a trick for multiplying by 9. Okay, so let's assume you want to multiply a number by 9 and you want to do it in your head and you want to do it as quickly as possible. How can you make it faster? Now, to evaluate multiplication by 9, simply multiply by 10, okay, then deduct the same number. Let me give you a simple one that I know you can do without the trick. So something like maybe 9 times 5, for example. Now, if you wanted to do 5 times 9, you could just say, of course, you know that I know. You could just say 5 times 10 and then remove 5. So 5 times 10 is 50. 50 minus 5 is 45. So now for bigger numbers, it makes more sense because, multiplication by 10 is very easy because all you need to do is add a 0 behind the last digit. So let's take an example. 22 times 9, for example. 22 times 9. Of course, most of us we are bosses. We might be able to do 22 times 9 very quickly in a matter of seconds. But if you feel you want to just know an additional trick you can use, you can do 22 times 10. Okay, 22 times 10, then remove 22 again. 22 times 10 is 220. That's easy to remember, easy to calculate. 220 now, minus 22 is easy. Another way you can do 220 minus 22 is to remove 20 first. Minus 22, you can remove 20 first and remove 2. That's another decomposition for subtraction. Maybe we'll talk about that later. So you can just say 220 minus 22 is 200 minus 2. That's 198. So it helps. Some of us might not like matrix, some of us might like it. So if you like it, you can use it. If you like it, you can use it. Okay. Now another one is multiplication by 15. So what if you want to multiply a number by 15? Now the trick here is multiply it by 10 instead. Multiply it by 10 instead. Now the answer that you will get from multiplying by 10, divide that answer by 2 and add it to the previous result you got. Let's look at an example so that you can understand it. So 17 times 15, for example, now. 17 times 15. Now what you simply do here is you do 17 times 10, then get your answer. That's 170. Then do half of 170. 170 divided by 2, right? That's easy. That's 85. So 170 plus 85 gives you 255. Okay, so that's that. So like I said, mental matrix are not things that you have to use. They are optional actually. So if you like them, you use them. So maybe another time we'll talk about tricks for making addition faster. Okay, so that also you can make your addition and subtraction faster. Alright, so that's that for our segment on mental matrix today. It's not so much. So let's just move on. We were talking about quadratic equations in the last class. Don't forget, we were talking about quadratic equations in the last class. So we're just going to continue. Remember, I told you that we weren't able to do everything in one class. So we're just going to try to do the concluding part today. So quadratic equations. Let's take a review. Remember, quadratic equations are usually in the form ax squared plus bx plus c equals 0. Where a, b, and c are rational numbers, and a must not be equal to 0. Now, the ways of solving these quadratic equations, we talked about 4 methods: factorization, completing the square method, quadratic formula, and graphical solution. We were able to touch the first 3. We were able to touch the first 3 in the last class. So today we are going to start with the 4th one. I hope you see remember the quadratic formula. Quadratization involves finding factors, of the first and the third term multiplied together. And when you add those factors, will give you the middle term. Completing the square involves finding the magic number, and using it to complete the square, and then solving for the quadratic formula. Who remembers? So if you remember it, you just say it to yourself. I'll give you 2 seconds to say it. Okay, so the formula is x equals to minus b plus or minus square root of b squared minus 4ac all over 2a. Clap for me, I got you right. Okay, so that's the quadratic formula. So we're starting with the graphical solution today. Okay, so if you have a graph paper, you can make use of that to try to work on your own solution. So let's start. Let's start. We don't have much time, and we have a lot to do today. So let's try to cover as much as possible. So how do we do a graphical solution? How do we carry it out? How does it work? Step one, equate that quadratic expression you were given, equate it to y, because you're going to be using an x-axis and a y-axis to plot your graph. So equate that equation, that's expression rather, to y. Step two, you set up a table of values for that equation now, for that equation that you have obtained. Then fill in the table with the appropriate values and then use the table to plot a graph. That's step four. Use the table to plot a graph. Now, step five, from the graph that you have plotted, check where the curve, you're going to use if you have a French curve, is an instrument, a tool that you can use to draw a curve. Okay, so you can try to get one. So you would read the graph to check where does the curve cut the x-axis. It might cut it at one point. In that case, that means you have equal roots, or you might cut it at two distinct points. That means in that case, you have real roots. If it doesn't cut it at all, then that equation doesn't have real roots. It means the roots are imaginary if it doesn't cut the x-axis. Okay, but that's a story for another time. So read the graph to check where it cuts the x-axis, and then those places or those points will be your answer. It's as easy as that. So let's take this step by step with an example now. So this is an equation. X squared minus 3x minus 10 equals 0. You have to use the graphical method to solve this equation. So first step, equate it to y. So you say y equals x squared minus 3x minus 10. That's step one. Now step two, you're going to plot a table of values. I will show you my own table, my completed table, then I will tell you how I was able to obtain each value. So you're going to plot a table of values that is supposed to look something, it's supposed to look like this. Okay, it's supposed to look similar to this. Now, you can use horizontal columns or you can use vertical columns. It depends on you anyway. Now, for x, first of all, you create a column for x, create another column for x squared based on your equation, create another column for minus 3x, and create another column for minus 10. Then create one last one for your final answer, which is y. Now, for your x, for the values you're going to use for x, if you're given, they might give you a set of values to use for x. Sometimes they may say use minus 3 to 3, okay? But if you're not given, you can just use from minus 2 to 2. It's always good to stay on the safe side, take some negative, take some positive, and use them together. So minus 2, minus 1, 0, 1, 2, right? Now, the next column, now that first column is something that you're not calculating. You're just taking the values based on either what they've given you or what you want to use. Now, the next column you have to calculate. So x squared now, we're going to calculate for each value of x. Take note. So for x squared, when x is minus 2, x squared will be 4. When x is minus 1, x squared is 1. When x is 0, x squared is 0. When x is 1, x squared is 1. When x is 2, x squared is 4. Go to the next part, you have minus 3x. So you're going to be using minus 3 to multiply each value of x. Okay, so minus 3 times minus 2 will give us 6. Minus 3 times minus 1 will give us 3. Minus 3 times 0 will give us 0. Minus 3 times 1 will give us minus 3. Minus 3 times 2 will give us minus 6. So that's for minus 3x. Now for the constant minus 10, it's called a constant because it doesn't have any variable x attached to it. So you can just spread that out over each column. So minus 10, minus 10, minus 10, minus 10, minus 10 everywhere. Now to get our y, which is the column in purple that you can see there, to get our y, we're going to add everything in red, column by column. Okay, we're going to add everything in red. So let's start with minus 2 now. For the column for minus 2, we're going to add 4 plus 6 minus 10. We'll get 0. Next one, 1 plus 3 minus 10. We'll get minus 6. 0 plus 0 minus 10. We'll get minus 10. 1 minus 3 minus 10. We'll get minus 12. and 4 minus 6 minus 10, we get minus 12. So that's how we arrive at the terms in purple, which stand for y. Okay, so this table, if you cannot get this table correctly, there will be an issue. So try to get your table correctly. You can always cross-check, as many times as possible to be sure that you haven't made a mistake. Okay, then after you've been able to, if you're able to successfully, get this table. Now this table is dependent on your own personal equation, on your own equation. So if you're able to get this table successfully, now you need to now plot, okay? So you're going to use the column in green for your x, for your values of x, and you're going to use your column in y for your values, your column in purple, sorry, for your values for y. So you're going to be plotting, y on the y-axis, of course, the values there in purple on the y-axis and the values in green on the x-axis. So I think you can see my graph now. So if I do that properly, and if I plot my graph properly, we would get something like this. And when you join the points together, you get a curve like this. So what we're going to do is, I know some of us, I don't know if some of us are familiar with the plotting of graphs, but if you're not familiar with that, we'll dedicate another class, to plotting of all types of graphs, linear graphs, quadratic graphs, and all types of graphs. But basically, if you know how to plot a graph, then you know that, okay, let me just go back a little. You know that when x is minus 2, you would mark off y as 0. When x is minus 1, you mark off y as minus 6. Whenever x is 0, you mark off y as minus 10. That's on your own graph now. You can try it out and see if you get the same thing with me. When x is 1 now, you get minus 12 as y. You mark it off as minus 12. And then when x is 2, you mark y as minus 12 also. Now, take note that before you can even plot a graph, you need to be careful of some things. The scale you're going to use, the scale you're going to use is important. The, position of your x-axis and your y-axis is also important. It's important that you put it in the middle, since you're having both negative and positive values, as you can see on the graph. So if you do that well, you should get something like this. So if you're not so good in graph, when plotting up graphs, you can indicate in the comment section so that we can, schedule another time for, plotting of graphs on its own. So now the next thing is to check where the curve cuts the x-axis. So this is the x-axis here. Now the curve cuts the x-axis at 2 points, 2 distinct points here. One here is minus 2. If you're looking at the scale, the scale here is 1 centimeter represents 5 units. So if you count each box, if you can count each box, you have 1 here, minus 1 here, minus 2, minus 3, minus 4, until you get to minus 5 here. So that means that this point here is minus 2, and obviously this point here is 5. So that means automatically that our graph cuts the x-axis at minus 2 and 0.5. So our solution for this equation is x equals 2 to minus 2 and 5. So minus 2, 5. So that's the graphical solution. The graphical solution simply hangs on, or is dependent on your ability to plot a graph correctly. Okay, so if you know you're having any 1 or 2 issues with plotting of graphs, you can do another separate class on how to plot the graph. So let's move on. Now, what about this? I told you we're also going to do some manipulation with roots. So what if you're asked to form an equation and they've given you the roots? How do you do that? So now, given that the roots of a quadratic equation are x1 and x2, the quadratic equation can be expressed as x minus x1 into bracket x minus x2 equals to 0. That's it. So simply take x and use, subtract each root from x, multiply that together and equate it to 0. Then expand as much as possible. Let's take an example. So you don't just, get confused. So look at this. For example, you are to find a quadratic equation whose roots are minus 2 and 5. Okay, so in this case, our x1 is minus 2, that's the first root is minus 2x1, and our second root x2 is 5. Okay, so what do? So we're going to look at x minus x1 into x minus x2 equals to 0. Now, wherever we see x1, we're going to put minus, take note of the minus, we're going to put minus 2. And wherever we see x2, we're going to put 5. Okay, so it's going to look like this. X minus 2 into x minus 5 equals to 0, right? Okay, so now, of course, you know that minus times a minus gives you a plus. Okay, so we have x plus 2 instead of minus now into x minus 5. Now, it's easy from here. It's very easy from here. You are going to now expand. So you use x to multiply x minus 5, and then you use 2 to multiply x minus 5. So x times x is x squared, x times minus 5 is minus 5x, 2 times x is 2x, okay, and 2 times minus 5 is minus 10. So by the time you simplify further, minus 5x plus 2x gives minus 3x. Now this equation becomes x squared minus 3x minus 10 equals 0. Now I chose these roots on purpose because they were the roots we got from the graph. Now you can see that we got from our graph, we said, oh, the roots of that equation, the roots are minus 2 and 5. Now we have now used those same roots and we have gotten back the equation. We've gotten back the original equation that we tried to solve using the graphical method previously. Okay, so this is the concept that you should follow, or the steps you should follow when you're given roots and you're asked to find the equation itself. Okay, so now there's another variant to this. There's another variant to this concept. You could be given the sum and the product of the roots. You could be given the sum and the product of the roots and not the roots themselves. So what do you do in that scenario? Now, given that the roots of a quadratic equation are x1 and x2, the quadratic equation can be expressed as x squared minus, now x1 plus x2, that's the sum of the roots into bracket x plus x1 minus, sorry, x1 times, that dot there stands for times, so x1 times x2, which is the product. So what that simply means is x squared minus sum of roots times x plus product of roots. It's actually easier than the other one. Don't worry, you get an example now and you understand. So x1 plus x2 is the sum of the roots, and x1, x2 is the product of the roots. So it's actually more straightforward. So let's look at this. For example, you're to find the quadratic equation if the sum of its roots is minus 1 and the product of its roots is minus 12. So let's go back to our original expression. X squared is x squared minus, the equation is x squared minus x1 plus x2, close bracket x plus x1 times x2. Now, but our x1 plus x2, that's the sum of the roots, is minus 1 here. So wherever you see x1 plus x2, you just need to put minus 1. Then wherever you see x1 dot x2, meaning x1 times x2, you just need to put minus 12. So it should look like this. Okay, so our x1 plus x2 is minus 1. Okay, let's just write that out. x1 plus x2 is minus 1, and our x1, x2 is minus 12. So what we're going to get now will be x squared minus 1x plus minus 12. So we're just doing a simple substitution here, and we equate to 0. Now, by the time we simplify, remember that minus times minus is plus, while minus times plus is minus, okay? So we should have x squared plus x minus 12 equals 0. Now you can see this, I think this just takes a total of about four steps. In fact, it's not even so long. It's not so long at all. Okay, it's very easy, much easier even compared to the previous, concept. So when you're given the sum of the roots and the product of the roots, remember this formula. We can actually derive the formula. You can actually derive it, but we're not going to discuss the derivation. But you can try to even check it out and see how this formula was actually derived. And you can just give me feedback if you are able to check on it. So x squared minus x1 plus x2 into x plus x1 x2. So that's that for forming the quadratic equation from the product and the sum of roots. Now, what about forming a quadratic equation from a graph? Now we've talked about solving a quadratic equation using the graphical method. Wouldn't they just give you a graph and you just say, okay, quadratic, find the quadratic equation that this graph represents? What do you do? What do you do? So let's look at this. So first of all, you read the graph and you check the points where the curve cuts the x-axis. Okay? Then next you put the roots into that original, the first one we looked at, into that equation x minus x1 into x minus x2 equals 0, and then you simplify and get your equation. Okay? So let's look at the graph. Let's take an example of the graph. So this is a graph. Form an equation from the graph below. So look at this graph. Look at this graph. So what the first step is to check, where does the graph cut the x-axis? So it cuts the x-axis in two places here. This point, you can see the dots and this dot here. So the first point here is -2 on the left, where it cuts the x-axis on the left, and where it cuts the x-axis on the right is 3. So automatically from the graph, the roots are -2 and +3, right? So we can read the roots from the graph. Now we're not going to take those roots and put them into our equation. So remember that we have the roots as -2 and +3. So we have x minus x1 into x minus x2 equals 0. Okay, so we're going to put -2 wherever we have x1. And we're going to put 3 plus 3 wherever we have x2. So let's look at that. So x minus -2 into x minus 3. Okay, now minus times minus is plus, don't forget that. So x plus 2 into x minus 3 equals 0. Now all you need to do here is now to expand. So x times x should give us x squared. X times -3 should give us -3x. 2 times x should give us 2x, and 2 times -3 should give us -6. So by the time you add and you simplify further, you should have x squared minus x minus 6. Now, if you want to check, you can always check, anytime you're dealing with these equations, you can always check if you're correct by, resolving the equations and seeing if you will get those roots again, or even putting in those roots and seeing if you get 0. That's a quick way to check. If you want to be sure that, x squared minus 6 minus x minus 6 equals 0 is my actual equation, you could just substitute -2 into it and see if it gives you 0, or you could substitute 3 into it and see if it gives you 0. That's a quick way to check if your answer is actually correct. Okay, so that's that, um, you know, graphical forming an equation from the graph. Now, word problems, this is the last thing we're going to look at. So what if you're riddled with a word problem? I know some of you don't like word problems, but they are easy if you take them one step at a time. So what if you have word problems, and then the word problem for this one now says the product of two consecutive positive integers is 132. Frame an equation for the statement and what is the degree of the equation, okay? But we are going to not just frame an equation, we're not just going to frame an equation, and we're not just going to tell us the degree, we're going to solve it. So let's look at that. Now, remember that they said consecutive integers and they are positive. I'll tell you why you need to take note of positive. Now, consecutive integers are integers that, follow one another. For example, 2 and 3, 5 and 6, 8 and 9. Okay, so I'm just dealing with positive ones. I'm just giving examples. So let's look at that. So since we don't know these integers, let's say that the first one is x. So automatically the second one will be x plus 1, since they are immediately following each other. Now the question says that product is 132. So product is x times x plus 1. So x into x plus 1 equals to 132, right? Okay. So that means that x squared, if we open the brackets, x squared plus x is 132. Okay? So that means that x squared plus x minus 132 equals 0. So this looks like the quadratic equation. Yeah. So we are going to now use the easiest possible method to solve. Let's use factorization. Okay? So we'll pick the first term and the third term, we multiply, and we get our answer. Okay, so that becomes, 132 squared. So that becomes minus 132x squared. Okay, now we now think to ourselves, what are the values of the factors of 132 minus 132 that when we add together will give us 1? That's the 10 in the middle, 1x. So that answer there is minus 11 and plus 12. Minus 11 and plus 12. Okay, so now what do we do next? We can now replace the plus x in the middle with minus 11x and plus 12x. Okay, so we replace this that term in the middle with those two terms, and then we have x squared minus 11x plus 12x minus 132 equals 0. Then we check x and x squared and minus 11x, they have x in common, so we bring that x. So x into x minus 11 plus 12x and minus 1 need to have 12 in common, so plus 12 into x minus 11 equals 0. So we pick one out of the two common brackets. So x minus 11, x plus 12 equals 0. Now, this is going to give us, we equate each one to 0. We have x minus 11 is 0, so x is 11. Now, this is a solution, and x plus 12 equals 0, and x is minus 12. This is not a solution. Now, this is not a solution simply because we were, we were told that the integers are positive. Now, minus 12 is not positive, so that's not going to be part of our solution. If when it wasn't specified, then it could be part of the solution. Okay, but since they said positive, we're just going to take x as 11. Okay, now, so if you were looking for the degree of that equation, this equation, of course, the degree is 2 because it's a quadratic equation. Okay, so let's continue solving. Now, x is 11, but we need to find the second integer. I know there are two consecutive integers, so the first one is 11, and the second one is x plus 1, that is 12. X is 11 and x plus 1 is 12. So the two integers are x and x plus 1, so they are 11 and 12. Okay, so that's that for first example. The last example now is on a rectangle. The length of a rectangle is greater than its breadth by 3 meters. If the area is 10 square meters, find the length and the breadth. Okay, so we have breadth. Let's call our breadth x. Now, the length is greater by 3 meters, so the length will be x plus 3. Okay, the length will be x plus 3. Now, this is our rectangle now. We can see our breadth is x, our length is x plus 3. So we have to find the area of this rectangle now. Always try to draw, if it involves shapes, try to draw the shape to give you a bigger picture of what you're supposed to do. So the area here of the rectangle, as we know, is length times breadth. Okay, so we can now substitute and say 10 as our area equals x into x plus 3. Okay, so that becomes 10 equals x squared plus 3x. That becomes x squared plus 3x minus 10 equals 0. Then, of course, use the easiest possible method. So we're going to use factorization. So we're going to pick this 2, and that gives us minus 10x squared. Okay, that gives us minus 10x squared. So that gives us minus 10x squared. And then we look for 2 factors, and that will give us, minus 2x and 5x. Those are the 2 factors that will add up to 3x. So we'll replace 3x with minus 2x and 5x. So we should have this. And then we factorize. X is common for the first 2 terms, so x into x minus 2, plus 5 is common for the next 2, so 5 into x minus 2. So we pick one common bracket, and that gives us x minus 2 into x plus 5. Now if we solve this, we get x equals to 2, which is a solution, and then we get x equals to minus 5, which is not a solution. Why is it not a solution? It's not a solution because x cannot be negative. The length of the rectangle cannot be, the breadth of the rectangle or the length cannot be negative. So we have x is 2 now. So the breadth is 2, and then the length is x plus 3, which is 5. So we've gotten the length and the breadth of our rectangle. Okay, so you can see in daily life sometimes you might see some problems that need you to be able to solve quadratic equations. You might not be able to solve those problems in daily life if you cannot evaluate the solution for quadratic equations. So it's important, very important. So in summary, we've talked about the graphical solution of a quadratic equation. We talked about how to form quadratic equations when you're given the roots or when you're given the sum and product of the roots, or forming the quadratic equation from the graph. We've talked about all of that, and we've also talked about, how to, use these quadratic equations, the ways to solve quadratic equations, and apply that to work problems. Okay, so you can try it out. Try, practicing more questions on all these things we've discussed, and try to, you can see how the formulas were derived, and try to also learn these formulas. So you can try this at home. Plot a graph of this equation, okay, that you can see now, and state what you notice. Just tell us, okay, you can give me, you can tell me in the comment section, okay, when you try to plot the graph of that equation, what do you notice from your solution, okay? Then you can find the equation whose roots are 4 and -2. So also tell me if you're able to get this answer. Then try this word problem. The sum of two numbers is 27, their product is 50. Find the numbers. Okay, try this problem. And then you can visit quizzes.com and you can play more games on quadratic equations if you want to. But try to solve the questions you can see and give me, feedback in the comment section. Don't forget to like. You can also comment, and you can share to your friends if you feel it will help them, to understand the topic better. So don't forget to hit subscribe for more updates, more weekly updates, and I hope you continue to enjoy the rest of your day. Have a lovely day. Bye.